After performing unit tests of the single components in our system, we may want to perform some closed loop testing, which means testing the whole BMS ECU against the plant model. So we can create a harness for the closed loop system. And in this harness, you can simulate the component under test in different ways. For instance, we can use some blocks from Simulink test, like the test sequence block, which is a kind of simplified version of Stateflow. And in this test sequence, you can inject some state requests for driving, balancing, charging, and then there may be some transition between the different steps that could be logical, temporal, or a combination. Okay, then we can use some dashboards to visualize the signals and to check whether there are some faults raised by our ECU. So we run the simulation in closed loop, and then we can take a look at some of the signals, like the temperature of the cells, the state of charge, the pack current, the voltages, and so on. And then here, by taking a look at the lamps, we can see whether everything is running fine or not. Well, so that's a way to test your closed loop system. But maybe there may be some occasions where you really want to check some conditions on signals which are really deep down the hierarchy. And maybe you don't want to modify the interface of your models. So to show this, let me open a different harness. So in this harness, I'm using a signal builder to excite the closed loop system, and I give some state requests. And now I want to check some conditions on signals which are really deep down the hierarchy. In particular, I want to check some conditions on these two signals, the discharge current limit and the charge current limit. But I don't want to modify the interface of my model. So to do this, I can use an observer. So I just right click on the canvas, observers, and then I add an observer here. So with this observer, I can essentially go and pick signals deep down the hierarchy without modifying the interfaces. And then I can check some conditions on them. So to do this, I click on this little badge on the bottom left. And here I can explore the whole hierarchy of my model. And I can select any signals that I want without changing the interfaces of my systems. So I just go to the BMS ECU, current power limits, and then I select the first output, which is the charge current limit. And then with this little Wi-Fi signal, I can add them to my observer. Just do the same for the discharge current limit. I add again. And now, as you can see, I have access to these two signals. Well, now I can define some conditions on these two signals, and I can use a block from the Simulink test library, and in particular, I will use a test assessment block. So I just open the block, and then here I can add my conditions. So I have added some conditions, and in particular, I use the verify statement to make sure that the charge current limit is below a certain threshold and the discharge current limit is above a certain threshold that I can define as constants here. Okay, so now this is inside the observer. And as you can see, I haven't changed anything in the main model. So now when I run the simulation, also the observer will run. So if some conditions are not respected, I will see this in the diagnostic viewer. And indeed here you can see that some of those conditions are not respected. And I have a nice description in the diagnostic viewer.